In this video, we'll continue our discussion of inequalities by doing some examples that have fractions in them. Now, you may remember how to deal with fractions in solving equations. This will be no different. And again, there are different ways, I should say, of dealing with fractions in equations or in inequalities, but I'll just point out some simple techniques that you can use to make these problems a little bit easier to work with. Do you have to use this strategy? You don't, but I think that it is helpful, and so we'll discuss a few examples of that here. All right, so I have the inequality negative 13x over 2 is less than or equal to x over 2 minus 15 over 8. Now my goal here is really to clear out all the denominators. I can't just remove them all, but what I can do is multiply both sides of this inequality by the least common denominator of all the denominators. And what that will allow me to do is to simplify these numbers from fractions down to whole numbers, to an equivalent inequality that uses whole numbers instead of fractions. So how am I going to do that? Well, the first thing I need is a least common denominator, which is also known as a least common multiple of 2 and 8. The least common multiple is the smallest number that can be evenly divided by both 2 and 8. Now, this number, because it has to be divisible evenly by 8, it can't be any smaller than 8. And so it turns out that 8 is the smallest number that can be evenly divided by both 2 and 8. And if we use that number, we'll see how we can clear away all of the denominators or simplify the inequality down to using only whole numbers and whole number coefficients. So what I want to do, multiply both sides of the inequality by the least common denominator in all the denominators. Now I'm going to take this extra step this time. What we want to do is to multiply each term individually by 8. And let's see what happens. So when I multiply 8 times negative 13 over 2, we can use what is called cross-canceling, and we will get 4 times negative 13x. 4 times negative 13x. And that's going to be less than or equal to 8 again divided by 2 is 4 is less than 4x. And then finally 8 and 8 cross cancel, and we're going to have minus 15 there. So we've simplified this a lot. We don't have those complicated fractions. I still do need to multiply out 4 times negative 13, which is negative 52x less than or equal to 4x minus 15. Now at this point, I can either leave my x's on the left side, and when I divide by a negative number, which I will have, I will reverse the direction of the inequality. So I'm going to subtract 4x from both sides here. When I do, I have negative 56x less than or equal to negative 15, dividing both sides by negative 56. Now, once I say to myself, I'm dividing by negative 56, I want to remember I have to reverse the direction of the inequality. So I change it from less than or equal to greater than or equal to, and now I have x is greater than or equal to negative 15 over negative 56 is a positive 15 over 56. And so that is going to be my solution to this inequality. And again, I do suggest that you take some time to check your answers to this. Try a number that's greater than 15 over 36. Once again, you can use simple numbers. In this case, any whole number that is greater than 1 would be a great number to test here. You could also test some numbers less than 15 over 56. 0 might be a good choice for that. All right, so we're going to go ahead and graph our solution here. When we do, we have our number line. We set up 15 over 56. Since there is an equal sign here, we are going to include 15 over 56 in the solution. So we start with a closed circle or a solid circle at 15 over 56. We graph in the direction of the solution, not the original inequality. We graph in the direction of x greater than or equal to 15 over 56, which is to the right. And so that is our solution to um, the original inequality. We'll go on to another one. You try. We have 1/2 x plus 3 is less than 2/3 x. So if you think you can do this, please pause the video, work through it yourself, check your answers, and come back and compare with what we have here. Just a hint, common denominator will be 6 in this case, and so begin, restart the video when you'd like to check your solution. Okay, so we have 1/2 x plus 3 less than 2 over 3x. And I'm going to multiply both sides of the equation. That means every term of the inequality. We're going to multiply every term in the inequality by a positive 6. And that's going to help to clear all the denominators and simplify the inequality to working with whole numbers and whole number coefficients. Those are the numbers that are multiplied times x. All right, so I'm going to take the extra step here. In future videos, I may not do this, but I take the extra step to show how I'm multiplying each and every term by a positive 6. When I do, 6 over 2 is going to give me a 3, and so I have 3 times x, which is 3x. 6 times 3 is 18, less than, here, cross-canceling the 6 and the 3 gives me 2, then 2 times 2x will give me 4x. So I did take 2 steps there and make sure that you can follow that. Now I can use either what I call the green method, the blue method. In this case, because I have nothing else on the right side, I'm actually going to subtract 3x here. So sometimes I'll use one method and sometimes I'll use a different method. It's great to be able to have both methods in your toolkit there. So what we have here is that 18 is less than x. We're going to read it from right to left. X is greater than 18. Write it the way we read it, and there we have our solution to the original inequality. Let's go ahead and graph this now. So we have our number line. Because 18 is not included in the solution, there's no line underneath the greater than, so there's no equal to here. We want to have an open circle at 18, then we're going to shade in the direction of the solution, which is to the right, and there is a graphical representation of all the possible solutions to the original inequality. We can take any number in the shaded region, plug it into the original inequality, substituting for x, and we will end up with a true statement. And since these are more complicated working with the fractions, I would like to have still one more example of this, so hopefully you can get a better feel for how these work. Now, if you feel confident that you could do this, please pause the video, work through the exercise, and come back and check your answer against what's here. In this particular case, we have only one type of denominator, that's a 6, and so the secret here will be to multiply both sides by 6. If you think you can do it, pause the video and return when you're done. All right, let's get started. So what I want to do, I'm going to start by rewriting my inequality. 5x over 6 minus 5 is greater than x over 6 minus 9. Then I'm going to multiply each term in the inequality by a positive 6, and when I do, we will reduce the inequality to all whole numbers and whole number coefficients, or integer coefficients. Okay, so we begin. Each term is multiplied by 6. These 6's will cross cancel and we get 5x. 6 times 5 is 30, greater than. 6's cross cancel. I have x minus 54. In this case, I will leave my x's on the left side. So I'm going to subtract x first. And when I do, I end up with 4x minus 30 is got to be greater than negative 54. If I subtract, I'm going to rewrite over here, 4x minus 30 greater than negative 54. If I add, rather, 30 to each side, I will end up with 4x is greater than negative 24. This time I'm not dividing by a negative number, so I don't have to reverse the direction of the inequality, and I get x is greater than negative 6. So on my graph, which has already shown up there, I don't include negative 6 in the solution. There's no line underneath the greater than symbol, and so we start with an open circle at x is equal to 6. We shade in the direction of the inequality, which will be to the right, and that is a graphical representation of the solution set, all the possible solutions, all the possible values of x that can be substituted in the original inequality to end up with a true statement, right? So this is how we work with inequalities, uh, fractions in inequalities, an important strategy that will also carry over into solving equations that involve fractions. Once again, the key is to multiply each term in the inequality by the least common denominator of all the denominators. So we'll end this video here.